Implicit differentiation is basically an equation that doesn't have y isolated. So far, everything that we have taken the derivative of had y isolated on one side, and we were just taking the derivative of x. Notice in this example, the first one that we're looking at, we have x squared plus y squared equals 25. Does anybody know what that's the equation of? Yeah, a circle. Good. I actually can't remember. I feel if you did that last year, because of last year was an unusual year. So if you didn't know that, no big deal. You probably didn't go over that last year. I don't think I taught it in Pre-Calc 12, or maybe you've not even taken Pre-Calc 12. This is the equation of a circle. That doesn't even matter. We could do this all without knowing that. I just figured I would tell you. So let's go through learning what we would do with this. Basically, the one and only thing you need to know is we're going to go through everything the same way. So we're going to take this and we're going to find the derivative of it. We all know by now that that's just 2x, right? So we take the normal derivative as we normally would. And then when we get to this part, plus, we're also going to take the derivative of this. We haven't gone through that, but what do you think the derivative of that is? 2y. So far, so good. Here's the only new thing. Okay, that's kind of new, but not really. Like, big deal. So it's not an x, it's a y. Do you see it's the same thing? The only thing is when you take the derivative of a y value, when it's all like embedded within the equation, we also have to put a y prime after it. We don't do that when we take the derivative of x, but we do when we're taking the derivative of y. And then we also need to take the derivative of the constant that's on the right side of the equation, which is just equal to what? It's just equal to 0. So we've dealt with that. We've dealt with that. So far, so good? Okay, the other thing I'm just going to mention off to the side here is, you know how we found this y prime? How else could I write that? dy dx. Remember that other notation? So I'm just going to tell you that, but I feel like y prime is what you're more familiar with. It's just easier to write. It's less stuff to write. So let's just use y prime so that we can focus on the skill. The rest of this is basically just using our algebra skills to get y prime by itself. So how I would want to do that is I need to get rid of this. Back to basic algebra, if I want to move that 2x over, everybody see we're going to get negative 2x. And then what we're left with is 2y times y prime. And if I want just y prime by itself, what do I need to do with this 2y? Divide it on both sides. That gets rid of it. So after all that work, y prime is simply equal to we can just get rid of those, right? So it's just going to be negative x over y. There's our answer. Let me take you back here. If it asks you to find y prime or find dy dx, this is all that we do. It's just that one new little step. After you take the derivative of y, you have to put a y prime there, and that's the thing that you're looking for. Good? We're almost done. This is crazy. Okay, so then I figure it's probably good if we go through one that's appears more challenging, but I swear it's actually not. We're going to set it up in a way that it's not going to be a big deal. Do you see that the stuff that looks like it's hard is never really difficult? It's just usually a little bit longer. There's more terms. There's a bit more stuff going on. But if we take that little step-by-step approach, I think you'll find it's not that bad. So we want to take the derivative of this thing. Let's take the same approach. Go ahead and tell me what's the derivative of the first term. 10x to the 4. So we've dealt with that one. So basically I'm using the colors to make it super clear. which is which and what's going on here. So if you break it into little steps like that, it's not a big deal. It's all the same old stuff we've been doing. Okay, so this has a little bit more going on because I need to take the derivative of this purple term, x to the 4y, but I need to take the derivative of the x to the 4 part and the y part. So which rule am I going to have to use to do this? The product rule. Everybody clear on how that shows up and what I mean? So let's sort of slowly go through this. What is that going to look like? I could call this my f and this my g. Are we all pretty good with like memorizing or knowing the product rule? Okay, so what would the first part of this look like? It's going to be a plus. What does it look like after I take the derivative of it? Well, do you see it? Let's do fg prime to start with. Okay, so if I do fg prime, what am I going to get? X to the 4, and then what's the derivative of this? A 1, but then I need to put the y prime there. Everybody good with that? Do you want to do one with the dy dx in there, or are you good with y prime? Y prime is fine? Okay. So there's the first portion, but we're not done yet. We still need to do f prime g. What does f prime g end up looking like? This is f. So f prime g ends up looking like, or like, what's the derivative of this part? 4x cubed, and then g is just the y value. So do you see I can just leave it as y? So far so good? Do you see this is more like an organizational thing? So if the colors help you, like you can see the potential to leave something off here. These are the most common mistakes I see people making. So do whatever you need to do to keep yourself organized. Good? It usually just means you can't be lazy and you have to spend another few steps to write stuff down. And that'll eliminate little mistakes. What's the derivative of this last term here? Plus, yeah, and then I need to also put y prime. Do you see that so far? Yeah, it's a bit different, but not like the only new thing really is that whole y prime part. And then what is it all equal to? It's just equal to 0. Question? Yep. Because it's in this step that we did f prime, or sorry, fg prime, and then the other part I did f prime g. So this is the only part where I actually took the derivative of the y. Right? Because of the product rule, so it's having us think back to the product rule. Steven? Here? Wait, is that what that I just... Oh yeah. It is 1 times y prime, but we just don't need to write the 1.
Oh, and then some other,
yeah. Are we... These are all good questions because I do think this is the getting the clarity and understanding where things come from. So anything else that's a little unclear? So far it makes sense? Okay, now the rest of this is just basically algebra. We want to collect our like terms. Well, actually, sorry, not really like terms. Let me rephrase that. I want to get y prime by itself. Do you see that term has a y prime and so does that one? Everything else I'm going to shove off to the other side. Sorry, you guys, but at this point I'm done with the color coding. Well, actually, okay, fine, I can do it. Let's move this to the other side. Do you see it's going to be negative 10x to the 4? And that allows me to get rid of that. Or maybe a better way to do it is to check it off so you can see what's happening. And then when I get to here, I can do minus 4x cubed y. So I'm going to check that off to show that I've moved it over and gotten rid of it. And what's left on the left side is this first term here. So I still have my x4y prime, and then I have plus this blue term over here, plus 5y to the 4 y prime. I'm just writing out every single little step so you can see where it's coming from. Do you see what I've done? I just kept the terms with y prime on the left. The other stuff I've moved off to the right by changing the sign. And then if I want to get y prime by itself, what's my next move out of here? Yeah, factor out a y prime. Everybody good with that? What's left is the x to the 4, so this part here, plus 5y to the 4, and equals, and now I'm done with the color coding, minus 4x cubed y, because I feel like you know what's going on now. So we can get rid of that. Good? Last step. My whole goal was to figure out what y prime is equal to. What do I need to do as my last move? Divide this out, right? Divide it on the other side, so I have y prime equals negative 10 x to the 4 minus 4x cubed y all over x to the 4 plus 5y to the 4. I look at it and check, is there anything I could simplify, reduce, or like, is there any way to clean this up at all? Anything that can be factored? Basically anything I could do? No. So we're good with that? Let's say I gave you a part B and I said find the slope. So find the slope. We don't even have to do this. I just figured so you could see the application. Find the slope of the tangent at the point 1, 2. Just a super quick run through of this. What would I do? Well, first of all, what is the slope of the tangent? It's the derivative, right? And we just found the derivative, right? So what do I basically do with that point? Plug it in. Do we even need to do that? So I'm just going to write it here. Plug into x and plug into y, and we would get negative 2 over 9. I'm going to assume you all know how to do that, but I wanted to talk about what it is that we found and how the application would look. So basically, to put things into perspective, everything that we've done is the same pattern of what we've been doing all along. The difference is now we're also taking the derivative of y when y is embedded within the equation. You're not even going to believe this, but here you go. Page 107. 1 to 3 odd letters. You all know what I mean by that. 4A to C, 5A, and 6. That is your work.